This tutorial is about whipped cream, aerosol, and I think the simulation turned out to be more like shaving cream. I haven't seen anything like it on YouTube. No, I haven't searched very well, but I'm gonna assume it's not there. Somehow you have this like honey-like cream buckling on itself, yet the whole thing kind of melts as it goes, and just a bit of an overview of how we're gonna do this. We're gonna start off by making a particle simulation that behaves like that rope. I kind of think of this as a nerd's rope. We're gonna then extract the curve that best fits that simulation, that kind of has the essence of it. Then we can shape it using various rules to get that star shape, and then do some volumetrics and a bunch of tricks along the way. This video is sponsored by Squarespace, and we're gonna talk about that later. Now, before beginning, it's of course important to do the research.
Okay, so we got a fresh can, and we're hoping this will be good reference and good food. Here we go. It's very good though. This is coconut flavor. So what did we learn from this little experiment?
Really all I want you to extract out of this is the whipped cream comes out in this like interesting shape. It's kind of like this star ridged thing. This isn't like a cloth simulation on a piece of string because this needs to collide with itself in a way. I'm going to be using an add-on called Molecular Plus. It's an upgrade on the original Molecular add-on from like 9 years ago, and you could think of it as Blender's default particle system, but now the particles can link and collide with each other. It's going to be in the M panel, and we just need to make a emitter and a collider. The collision is going to be on a plane, whipped cream directly on the plate, and then you can think of the emitter as roughly a mesh circle, F to fill, bring that a bit upwards. This can be our emitter that can rotate and move as the can itself moves. To make this an emitter, click emitter. To make the thing a collider, click collider. By default, this is going to behave just like a normal particle system would, and the worst offender, these particles actually start by going upwards instead of the velocity the normal it inherits going directly down. Flip that bad boy 180 degrees. And just with that, it is already emitting in the correct direction. You might be wondering why is this not behaving differently, right? We got Molecular Plus. What's all the fuss about? What's the hype? Unlike normal particle systems where you just hit play to simulate, all you need to do is you need to use this button to simulate. Click simulate.
Oh, yeah.
To get them to not just push outwards, but also link, enable linking. So these first two are just colliders, essentially. When we hit simulate, is going to turn this into a rope that, I mean, it already kind of buckles on itself in a pretty good way. The rest of this is just finding the right settings that make it not look like a jelly string. Well, first of all, these particles are coming out quite big. So you can take your voxel size, make it twice as small. This is basically the particle size. And now what I like about this is it's coming out like not as a solid string, but almost like this gooey thing, but now it's kind of losing its form. So I'm just going to make the voxel size a bit bigger. And another thing is I want this collider to have the whipped cream stick to it. It shouldn't slide and wiggle around as much. You could think of this as adding stickiness to the plate. By the way, I found if you go above 1, weird things happen. So I'm going to say like 0.7, and there's going to be no friction, no, 100% friction and 100% damping. That means when it collides, it's not going to bounce back up, nor is it going to slide around. I mean, honestly, that's already most of the way there. Once you get above the frame that you stopped simulating, here it goes, boom, it becomes a basic particle system. So to secure this, hit this current cache to bake button, which will take what we did and actually save it. So this is pretty good, but it's still behaving very jelly-like. On top of linking, which is what lets these particles keep together, I'm going to go to the physics, which has all of these Molecular Plus settings, and I'm going to enable relinking. Relink says if particles end up near each other, there's a chance they could relink, and I'm going to make that 10%. It's going to like stick together more. And if you go too high, like I think I did right now, it's going to build more of a tower. So in fact, it's like linking a little too well. So maybe only like 4%. And all of these particles I think should be coming out faster because of the pressure of the aerosol. So while this is using Molecular Plus, under the hood, it uses a underlying particle system that we can totally change the velocity of. So the normal is how fast it shoots out. Let's make that 3.5 and add a bit of randomness so it doesn't shoot out exactly straight. And now this is giving me that property that I like, where it doesn't come out perfect and it also buckles on itself. I think the only thing that can make this better is we kind of just increase the detail. So voxel size, which is the size of the particle, I'm going to make it smaller so these particles come out half as much. And to account for that, the number of particles, I'm just going to quadruple it. When you do that, you want to hit this refresh button, which will calculate how many substeps, how much compute. By the way, fucking hate how the AI people, which is all I watch now, they talk about compute.
Significantly less compute.
Computes more compute.
Test time compute. 1,000 times more compute. 1,000x compute. Compute. Massive amounts of compute. Get a lot of compute.
Powerful training compute. Training compute.
I don't know how to explain it. It's just this slang I'm not into. That being said, the sub-steps, when we hit this refresh, it will tell us how much compute we need to make a good simulation since we have so many more. I just want to do one more thing. I think the reason it's building on itself without any variety is, of course, because this emitter isn't moving at all, so it's just shooting downwards. This can be animated. So if I want to rotate it on this dimension, it looks like I'm just rotating it. Why is there a number bigger than 0? That sounds like a glitch. I just need to rotate it on the y-axis. Specifically, I don't want to do this myself, so I'm going to make a driver. So this is just going to make it insane. Let's turn that into the sine. So this is going to make it oscillate back and forth. And let's make that slower by saying take the frame number and make it 10 times slower. It's still going to have the same properties where it like sticks together and collides, but now it's like more like string. What am I thinking of? String in a can? I don't know why I can't remember what this is called. But it does have that nice property. The only thing I want to change is it shouldn't be going as far. So maybe it can only go 5% as far. I just kept 70 frames because this is going to get heavy very soon. I'm going to call this our particles. This is going to be our collider. We need to mesh this because if I was just to render this as particles, it would just look like weird ejecting sand. So this is where the tricky geonodes part kicks in. So I'm going to go to tools. I'm going to hit convert to geonodes. What this is going to do is it's just going to apply a simple setup we could have made on our own. It makes a particle instance. So it just kind of inherits these dots. And then the second thing is it uses geometry nodes. It's really just going to take these vertices and turn them into points with a material. That's fine, but I don't want a material. So in fact, I can just disable that. And now we need some clever approach to take this data. We have nothing else. We don't know their velocity. We don't know their age, and turn this into something that looks good. My solution is I'm going to make a curve that basically represents the flow of how this came out with all the buckling, etc. If I get that curve, then everything else I can make. I can sweep the star shape, add noise, voluminize it, everything. Okay, so how are we going to do that? Well, one thing I want you to see is we basically have nothing with our points. We have the position and the radius, but we have this kind of like explicit, I don't know, this implicit field that tells us the index. But because they spawn over time, that index is also going to grow over time. If I take the index and I look at it in reference to our points, which right now is going to be completely white because basically all of these have a index bigger than 1, except for like a single particle in the beginning. Here you can see that particle and then it's all white. I'm going to normalize this by taking the field min and max. This is a node added in 4.5. I'm going to take this field min and max, look at the integer, and I want to see what the biggest index is. I can now take the index and divide by the maximum and view that. So here you can see the bottom is black and it's kind of like an age of particle kind of situation. So at least we know what order they came out in, which should help us somewhat make a guiding curve. What about points to curve? Okay, that generates something. By default, it actually uses the index itself, but it's this kind of porcupine monstrosity, whereas I want it to kind of be the average going inside of this tube. One thing you might try, which makes sense, but hint, it's not going to work, is we take this curve and maybe we like smooth it a little. Take the position and I'm going to blur that vector. I do a few iterations and I mean, it kind of works, but the issue is there's still too much going on here. I just want the general form. I don't need every detail, right? This should just be this without all the insane coiling. Again, I can't just like turn this into a mesh and just hope that like merge by distance works with like a bigger distance. It's going to be unstable and flickery. This video is sponsored by Squarespace, which is the service I use to make my website, cgmatter.com, where I can make a membership system so these people get the blend files. I recently added a new feature where I can dynamically upload nodes into your asset browser, and all of this is possible because of one, Squarespace Payments, which allows all the membership money stuff to just work. The asset browser lets me store assets from my website all in the same place, and as you build your website, if it's getting big, extensive, there is direct AI integration. You can use it to design, to fill in content, etc. So if all this sounds good to you, head over to Squarespace, make a website, and when you're ready to take that thing and launch, go live. Use this link in the description to save 10% off your first purchase of a website or domain. And now, my people, I want to solve the problem of making a smooth curve go along the whipped cream. Well, the solution, like I said, relies in this index that tells us the order that stuff came out in. So here's the key insight. I'm going to separate this into blocks. So all of these particles are a block, all of these. We're extracting segments that come in order, and then this one represents a point, this one represents a point, this one does, and we connect these with lines to get the averaged out curve. The way to get this to work is we need to preserve the ordering, but split it into groups, which we're going to call instances. We're going to split it to instances. I'm not just going to use the index, because then we get a lot of instances, and it's going to be crazy. Maybe we'll do them in groups of 10. If I take the index and I divide it by, let's say, 10, we might change this number later, so 10. The first few indices, so 0, 1, 2, all the way to 9, when we take this and divide it by 10, these are all going to be numbers under 1. So it's going to be 0, 0.1, 0.2, etc.
2 + 2 is 4, -1, that's 3, quick maths.
But if I now take this and like round it up or down, it doesn't really matter. Let's do round it down. These are going to form separate groups. Specifically, if I look at this, it's going to form 1,400 instances. Instead of having, what did I do wrong? 14,000 points? Oh, no. That makes sense. We divided by 10. So let me show you the groups. Here's like the index 0, 1, 2, 3. They're each going to be their own thing. And you can see they all travel by themselves. So if I look at one of the bigger ones, it's only going to eject later. For each of these instances, I want to merge all of these points, which should give me the average. Merge by distance, by like a giant number, and now we have this curve. Note that the number of points is exactly determined by our division. So if I make this really big, we now have exactly the guiding curve. That is stable. If we did any of the other methods, it would have flickered everywhere. And now, my friends that I've never met, we take points, we convert it into a curve. You're going to see it does nothing. Why? It's because there are no points. We took instances and merged them. That means there's still instances. So I'm going to realize those. And now we have a semi-stable curve. And then this curve in itself, we can also smooth. As simple as resampling it. And maybe we will not resample just normally, but we're going to do it by length. The longer it is, the more points it has. So I'm just going to divide by like 3 before and after. It's losing some detail, so make the length even tinier. And now we have something that pretty well represents the curve. We can now do our blurring operation. And there you go. So now we have the curve that perfectly represents this, but it's nice and smooth. So really the whole molecular plus simulation, the whole thing was just to get this curve. And the rest of it, turning it into the foam, we can shape with geometry nodes. So I'm going to take all of this and turn it into a node group. I want to be able to control this division value. And I probably also want to control the iterations of the blurring. I'm going to call this guiding curve. And this is what I want to mesh. So it's literally like take a curve, turn it into a mesh. Well, let's start simple with a curved circle. Just see what that looks like. So I connect that in here. It's huge. You can take the scale. So this is another thing new in 4.5. You can control the radius directly from the node. And while it does self-intersect, we're going to correct for that with smoothing and volumetrics. It does well represent the shape. Of course, I want that star pattern we were talking about, which there is a node for. By default, it's going to look like this, which I don't know. I guess I can count, but I think it's less ridges. So let's go with 6. I'm going to use this as the profile curve. And now it's looking whack because we need to get rid of shade smooth. Set shade smooth, turn that off. And now it's coming out like a star. It's wiggling, and we'll talk about that. But this is a shape we couldn't have gotten simply, I guess, with the molecular plus. So what's going on here? Why is it like twitching and rotating? When you like thicken a curve or turn it into a mesh, it needs to know how to put that profile curve on the curve, right? If I take the tilt, so I'm going to set curve tilt, and I orbit this, you can see it is free to rotate, but it doesn't know exactly where to put it. It turns out that what we're looking at, what we want to fix, is the curve normal. So right now it's trying to minimize twist. We can also have it do Z up, which is a different method. So this looks horrible, but it is stable at least. I just want to pick a normal that looks at the curve, but creates something that isn't a mess. I'm going to do a free curve. Here you can see you could like pick the direction and it will be stable. What I am actually going to use, if you can guess it, think about it right now, because this is a good thing to check if you get what's going on. What I'm going to use is I'm going to take this curve and I'm going to use one of the best properties about it, which is the tangent, not that one, but the curve tangent. There is a direction that flows along the curve. So you can think of the tangent as basically the direction that the curve flows, which of course will stick to the curve because it basically defines the curve. And if I use this to at least base my normals off of, it doesn't have to be this, but it can be based off this. Well, in that case, we are in the good business. So I'm going to set the normal to the tangent, which predictably is going to be messy. All I need to do now is just do something to this tangent. So one thing that might be sensical is you take the thing and you rotate it. So as I rotate it by anything, like even 1 degree, it sticks onto it. And maybe that's what we'll use. Probably like rotate by 90 is pretty stable. Another option is you can find a direction that is going to be perpendicular to the tangent. We can do that by taking the cross product, which I don't want to explain right now. I've done it many times, between the tangent and some vector. So let's say Z up, so 0, 0, 1. I'm going to set this as the new normal, and that's pretty good. Maybe the Z vector isn't the best choice because a lot of this curve literally just goes straight up and down. So I'm just going to pick something random, and automatically it's going to smooth this quite a bit. And just like that, we get the whipped cream buckling thing, which we're going to clean up, but you can see this is definitely a good start. So let's take some of these nodes and make them node groups. So I'm going to call this normal. Let's change the star, play with the number of points until like you feel that it looks right. I'm not going to think about it too much. I think that's, oh, God damn it. Tell me that it auto-saved. Tell me that it auto-saved. Recover, auto-save, top 1. Okay, amazing. What was I saying? I want to add visual interest to this because right now it's just coming out as a star and it doesn't twist or get thicker or thinner. Let's start with the twisting. We have this set curve tilt node. This is going to spin it, but what if we spin it in a spiral as it comes out? Well, we take the spline parameter, which tells us, I mean, it could tell us how far along the curve we are, which is what the factor does, but then this isn't necessarily going to be stable. stable, right? I want this to be length dependent so that as it gets longer, there'll be more tilt. So I'm going to make this length dependent. Let's make this a bit easier to read. So this can be our meshing. To see what this is actually doing, I'm just going to multiply it by a factor that will let me enhance or dehance it. So with 0, we get something like that. And then as I increase this, you can see it twists, but kind of over time, which should be stable as it comes out. It's not going to flicker. Another thing is our like modified profile star curve isn't very interesting, and it has these sharp angles that I don't like, which is going to make it look artificial. I'm just going to smooth that out a bit using a fillet curve that basically adds resolution to the corners and smooths them out. So I'm just going to add a bit of a higher count, increase the radius until it kind of looks very smooth, and then just to keep things stable, resample this. The whole reason for this is I might want to make UV coordinates on this later. So just increase the resolution, something like 50 should be fine. Let's also have the radius vary over time as this is ejected. So there can be a thick section and maybe there's a bit of a spray here. So this is a thinner section. We could do this randomly, or we can base it off of our like initial point cloud, which had thin and thick parts. I think I'm just going to do it randomly. Inside of our meshing, we need this scale to vary along the curve. We can do this by just adding a bit of noise. So this is going to be our radius. If I turn off normalize, that's going to be -1 to 1. Map range -1 to 1 to, what was it, 0.03? Let's say 0.02 to 0.04. And I want it to be a bit more intense. So let's make a bigger range. And this is going to basically be dependent on a 3D coordinate system, which makes it look weird. I want this to change as we go along the curve. For the W, which dictates the thickness, I'm going to use the spline parameter again based on the length of the curve. And now you can see the thickness kind of flows with it. Kind of hard to explain, but easier to see. I can like increase the amount of like, I don't know, variability and increase the detail and all of these things. It might be good to add another resampling based on length so I can choose the resolution of this. Yeah, that has way more detail. Bring down the detail, maybe bring down the scale a little, bring down the variability. Next, what I want to do is you can see this is a very destroyed mesh. I want to turn this into a nice smooth mesh that doesn't have all this chaos and bending. The basis of this is going to be going from mesh to volume back to mesh. Age-old trick. So mesh to volume. You're going to notice that there is no volume even if I bump up the density. Well, I guess there's something. So the reason for this is it's actually not a solid object, even though you might think it is, because the cap isn't filled here. In the curve, make sure to enable fill caps. And the moment we do that, we get a nice volumetric that I can increase the resolution of. And then finally, we turn the volume back into a mesh. Let's bump up the resolution again until we kind of have our star shape and it maintains the detail. Let's throw on a set shade smooth, bring down the density. Yeah, I think that works pretty well actually. And by the way, what I like about this is now this part of the mesh, which before would kind of be self-intersecting, it's actually connected. Why do I like that? That means I can now do a blurring on the entire thing. So if I set position, same trick. I'm going to turn this stuff into like a node group asset pack for cgmatter.com members, so you don't have to do it again and again. I'm going to take the position and blur it. And now this is nice and connected and it will look more like a single thing that melts into itself. Yeah, let's turn this all into a node group, remeshing. In the blend file I'm going to provide for the original thing that you saw, I'm going to include all the extra stuff. But for now, I think the last thing I want to say is this setup exists. It's good. If I change the particles, it's also going to then apply, I'm going to call this whipped cream, it's going to apply the same node group easily. We don't need to do it again. This time, let's do 200 frames, free all bakes, and then hit simulate and wait for this to finish. By the way, while we wait, I uploaded some samples to my Twitter. This looks so satisfying, holding myself from making stupid poop jokes. Is that doo-doo? This is what I aim to please. I mean, the whipped cream was basically like a white material that I feel like pretty well symbolized it. While I'm still waiting, by the way, join cgmatter.com. When you join, you're going to get all this stuff. Each one is a write-up. So the next one I'm going to do is going to be about, well, I guess it's going to be about this. It's going to be about aerosol whipped cream simulation. I mean, this looks good. I mean, it kind of looks like mousse or whipped cream or whatever. And we had this go for longer. And I'm saying the beauty of what we did. It's absolutely beautiful. If I now hide this result and bring back our geonodes, it will automatically update. You might see in a case like this, we need to bump up the radius. Fine, we can just kind of multiply the output by something a bit bigger. And notice we didn't really need to update anything. We just resimulated and then this was applied. We're going to throw in a bake node, which can bake a animation. And we'll take all of this process and just compress it into a single cache. I can hit bake and wait a moment. You're going to see when I scrub, now it's basically an in real time. And now if I play this, I mean, there you go. I mean, play with some settings and increase the resolution so it doesn't flicker. There you go. Whipped cream, mousse. What else has this property? Let's think. Silly string. A while ago, I was talking about some string. Silly string is what I was thinking of. Diarrhea, I believe, also has this property. And on that note, now that you're picturing that, I think it's time to leave. As always, cgmatter.com, get the project files, and soon I'm going to be adding a node add-on. I'm not going to talk about it too much because it doesn't exist yet. Goodbye, people. Hopefully you learned something.